Okay, so hi everyone. We will now see the hydrogen atom spectrum, the emission spectra of hydrogen. Now, emission spectra of hydrogen, if you see here very carefully, we have this hydrogen atom, electron is moving, and we have just bombarded the light. If you see carefully, that small blue dot jumping into the second orbit, coming back to the first orbit, then going to second orbit, and you can just see down there the spectrometer and small lines coming out. That's the spectra which you are getting. I am now considering my entire atom to be the Bohr atom, where we have the fixed orbits, electron moving in the fixed orbits, moving in circular path, and you find there the electron getting excited to the higher energy state. Then see very carefully. Now I take the atom. I will consider the atom to be the de Broglie atom, and when I say the de Broglie atom, then instead of considering the fixed path of electrons, we will have to consider the wave nature of the electron, right? So we will see the de Broglie atom after some time. You can very carefully see those colored bands which are coming. They are the Balmer series, which is coming in the visible region of the spectra, if you see there carefully, and in the ultraviolet region of the spectra down there you have the Lyman series coming, and in the infrared you have the Pascal bracket and Pfund series coming. Now I take the atom, we will consider this as if you see there, now we are considering it as a wave, right? So electron to be a wave. So just see how the waves are jumping from one energy level to the another energy level. The concept remains the same. So this proves that how we can consider the electron to be a wave-like property. Now, if you see here carefully, the wave which is moving is a matter wave. Rather, it's not a matter wave. It's a standing wave, right? It is vibrating at one place only, and that is precisely the reason why Bohr said that when an electron is moving in a stationary orbit, it does not emit any energy. I will just put on the energy levels also now. If you see the energy levels now, the energy levels, the electron moving from n equal to 1 to n equal to 6 now, coming back, it again goes up to 4 now, comes back, right? So this is what we had seen in the emission spectra of hydrogen, right? You see simultaneously you have to look down there in the spectrometer, the lines which you are getting, and this is the Schrödinger atom, where we consider the electron to be an electron cloud, not a wave but an electron cloud. So I return back to the Bohr atom. That is where the electron is getting excited to the higher energy state. Now you can just correlate them with the jumping of electrons, which you can see on the right hand side, and that makes the entire emission spectra very clear.